Krishnamurthy sir.
Yes, ma'am. I am ready, ma'am.
Yeah,
Madam,
ready.
இல்ல மேடம் 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 அவர் சீஃப் கெஸ்ட் சாருக்கு வந்து இது பண்ணி விடுங்க சார் ஃபோக்கஸ் இருக்காரா
Sir, Chandramouli sir is in. She is on mute. Sir, can you please unmute yourself, Chandramouli sir?
Now only I will push to unmute. Okay, it was unmuted actually. Yeah.
Okay, sir. Yes, sir. Yes, sir.
Thank you. You
Okay,
can
sir.
start.
Shall we
Yeah,
start,
please.
sir? Okay, sir.
Yeah, please. Go ahead.
Thank you, sir.
Yes, sir. Am I audible?
Yeah, please go ahead.
Yeah.
Sir, recording போடுங்க sir.
Uma ma'am, I can start.
Yes. Sudha ma'am.
Recording start பண்ணுங்க.
Sudha ma'am. Yeah.
Very good morning to one and all gathered here. We extend a very warm welcome to the invited guests, participants, and attendees. On behalf of SRM Institute of Science and Technology, Ramapuram campus, we welcome you all to the 2 weeks International Virtual Professional Development Program on Data Science, a revelation of modern digital era, organized by the Department of Computer Science and Application in association with SCIENCE&APPLICATIONS. This PDP aims to bring together leading academic scientists, researchers, and research scholars to exchange and share their experiences and research results on all aspects of data science. The most powerful moment of feeling with the worship is a prayer which seeks for nothing special but is a yearning to escape from limitations of our own weakness and an invocation of all good to enter and abide with us. Now, let us all stand up for Tamithai word.
Indumati ma'am. Ma'am, some echo is getting. Indumati ma'am. Okay, Indumati ma'am, you please unmute yourself. Tamithai வாழ்த்து.
திராவிடனர் திருநாடும் தக்க சிறு பிறை முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திரும்பி அந்த செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Thank you. We should strive to welcome change and challenges because they are what help us grow. Sir, you have motivated us all by being a living example of kindness and selfless service to our institution for the past 2 decades. You have given your best by sharing your expertise and knowledge in every possible way to help us in reaching greater heights in our career year after year. He is the man working towards connecting young minds to strive towards success and achievement. With that being said, let me call upon our respected HOD MCA and Vice Principal Admin, Faculty of Science and Humanities, Dr. J. Dileepan, to deliver the welcome address for the event. Please, sir.
Thank you, sir. A very pleasant morning to one and all. I extend a cordial welcome you all to this inauguration of the 2 weeks International Professional Development Program on Data Science, a revolution of the modern digital era. organized by the Department of Computer Science and Applications, SRM ISC Ramapuram campus, in association with Computer Society of India, Chennai chapter. First, I would like to extend my hearty welcome to our chief guest, Mr. S. Chandramouli sir, founder and director, 51 Technologies, Chennai, with a deep appreciation for accepting our invitation in spite of his busy schedule. Next, I would like to express my warm and special welcome to our beloved Dean of Science and Humanities, who is a constant source of motivation and inspiration for our growth. I take great pleasure in welcoming today's guest speaker, Mr. Jyoti Perisamy sir, board member at University of California, Chief AI Architect, DSP.AI USA. I take this opportunity to welcome our Vice Principal Academic Sir for his valuable support in all our academic activities. It gives me immense pleasure to welcome the participants from various institutions, event coordinators, and faculty members to this wonderful session. This purpose of this PDP is to enhance the skills and knowledge of the faculty members, research scholars in data science. As you are aware that the data science is one of today's most rapidly growing academic fields and has significant implications for all conventional scientific studies. It is a novel science in that its research goals, perspectives, and the body of knowledge is distinct from other sciences. So recently, data science is used in many industries like internet searches, digital advertisements, marketing, healthcare, finance, banking, policy work, social media, e-commerce, and more. So furthermore, a lot of research scholars doing the research work in data science, I strongly believe that we will be able to understand the key concepts, technologies to develop any future applications by attending this 2 weeks professional development program. So once again, I welcome you all to this wonderful session. Thank you.
He is our leader, working towards connecting young minds to strive toward success and achievement. He is known for his wonderful administration and high achievements of the institution he is in charge of. Let me call upon our respected Vice Principal Academic, Faculty of Science and Humanities, Dr. Asogan sir, to offer felicitations. Please, sir.
Thank you, Dr. Kishanmurthy. The most respected and beloved our Dean, Major Dr. M. Venkatramanan. The most respected Chief Guest for the day, Mr. S. Chandramouli, Founder and Director, 51 Technologies. One of our well-wishers and technical expert, most respected Mr. Jyoti Perisamy, Chief AI Solution Architect and Board Member of University of California. Respected HOD MCA Department and Vice Principal Administration, Dr. Dileepan, coordinators, conveners, and esteemed faculty members, and my dear day after tomorrow leaders and valuable participants. Very warm greetings and good morning to all present here. I'm very delighted and appreciate the MCA department for conducting 2 weeks professional development program on data science in association with the CSI Chennai chapter. Professional development program is an important subset of learning. It is often looked at as a need to have, but learning, a commitment to continual growth, is a great to have. Learning is not just an action, it's a mindset. The PDP is a personal commitment to a continuous journey of growth and self-improvement. As a specialty, data science is young. It grew out of fields of statistical analysis and data mining. Data science is an essential part of many industries today, given the massive amounts of data that are produced, and is one of the most debated topics in IT circles. Its popularity has grown over the years, and companies have started implementing data science techniques to grow their business and increase customer satisfaction. More and more companies are coming to realize that the importance of data science, artificial intelligence, and machine learning. Regardless of industry or size, organizations that wish to remain competitive in the age of big data need to efficiently develop and implement data science capabilities or risk being left behind. I believe and assure that meaningful and constructive learning will happen to all the participants for the next 2 weeks. Thank you very much.
Thank you so much for your inspiring words. Definitely, the participant will carry forward your advices to make revolution in the field of data science. Thank you, sir. He is an amazing person, a loving and caring leader, an adorable personality. People like him are hard to find. He is the face of our institution. Every one of us should try to inculcate some of the values he holds. Such selfless service is hard to witness. He is well known for his work in the field of education. Now, I would like to invite our Honorable Dean, Major Professor N. Venkatramanan, Dean, College of Science and Humanities, to deliver the presidential address. Please, sir. May I now request our Honorable Dean, College of Science and Humanities, to deliver the presidential address. Please, sir. Forum is yours.
So thank you very much. Very good morning to one and all present here for the 2 weeks international virtual program on data science, the revelation of the current scenario. At the outset, I would like to congratulate the head of the Department of Computer Application and Vice Principal Dr. Admin Dr. Dileepan for having organized this, and also the coordinators and the student organizers for this wonderful international virtual program on data science, which is very important in recent years, and it plays a vital role in the technological development and the importance of the economic development. As you all know, data science is the area of study that involves extracting insights from vast amounts of data by using various scientific methods, algorithms, and processes. It has emerged because of the evolution of mathematical statistics, data analysis, and big data. I would say that it is an interdisciplinary field that allows you to extract the knowledge from the structured or unstructured data. And also, it enables you to translate a business problem into a research project and then translate it back into a practical solution. And as you all know, the important concepts of data science is visualization, deep learning, and machine learning. Data science process goes through discovery, data preparation, model planning, model building, operationalizing, communicate results. And the various tools that have been used is, you all know, it is R, programming, R, SQL, Python, and so on and so forth. And I would say that the application of data science is very, very important, and the following are the important areas in which data science is applied. It is used for internet search. As you all know, Google search uses data science as a technology and search for specific results within a fraction of a second or a fraction of a minute. And it's also a recommendation system. It creates recommendation system like in Facebook. You suggest friends, you will be able to identify who it is, and it is easily done. And the third one is image and speech recognition. Speech recognizes system like Siri, Google Assistant, Alexa, all come from or are run from the data science techniques. Similarly, Facebook recognizes your friend when you upload a photo with them. The next one is the gaming world. EA Sports, Sony use data, science technologies, etc., enhancing gaming experience. And finally, I would say that the most important application of data science is on online price comparison. And finally, I would like to say the uses where data science is most applied in the recent years. It is a lubricant of today's world with the right tools, technologies, algorithms. We can use data and convert it into a distinct business advantage. The second usefulness of this is to detect fraud using advanced machine learning algorithms. Similarly, you can prevent any significant monetary loss. And also it allows you to build intelligence, ability in missions. It also can perform sentimental analysis to gauge customer brand loyalty. And again, it enables you to take better and faster decisions. And it helps you recommend the right product to the right customer to enhance business. And such as the users and the application of data science, I feel that this topic, data science, a revelation of modern digital era, is absolutely correct. And I once again congratulate the organizers for having chosen this topic and the VIPs, the chief guests who are here, and these guest speakers. I'm really happy, and on behalf of the College of Science and Humanities, I welcome both of you, sirs, Chandramouli sir from PI Technologies and from Deep Sphere. Sir, I wish this program a grand success, and I'm sure all the guests, the scholars, the faculty from various other institutions, researchers from other various institutions will be surely benefited out of your inaugural address as well as our guest speakers lecture. I wish this program a grand success. Thank you for having given me this opportunity. Thank you very much. God bless you all.
Thank you, sir. Thank you for showering your blessings on all the participants. Definitely the participants and ourselves will take lead of what is the content. And with your blessings, we will be reaching our goals in a simplest way. Thank you, sir. Now, it is the time for the chief guest. For men may come and men may go, I go on forever. This is the time much awaited. All of us have been eagerly waiting for this minute to listen to the chief guest for today's function. Before that, may I now request Dr. R. Renuga Devi, Assistant Professor MCA, to introduce the chief guest to the audience. Please, ma'am.
Thank you, sir. Am I audible, sir?
Yes, ma'am, you are.
Yes, thank you. A happy morning to all of you. If your actions inspires others to dream more, learn more, and do more, and become more, then you are a true leader. By John Adams. Today, we are having a true leader with us. It is a great honor for me to introduce and welcome our chief guest, Mr. Chandramouli, founder and director, Pi1 Technologies, Chennai. Mr. Chandramouli sir has 35 years of technology industry experience, and he is acting as a Chief Information and Technology Officer, Sancta Nethralaya, India's largest eye hospital. Mr. Mouli has been recognized as top 100 eminent CIOs of India for 4 consecutive years, that is from 2018 to 2021, for his pioneering work for a transformation program at Sancta Nethralaya, the India's largest eye hospital. His mission was to innovate at scale and deliver sustainable and affordable healthcare technology for the people, leading to lowering costs and predictable outcomes. His work on democratizing eye screening by leveraging AI and cloud-based telemedicine solutions was transformative and brought digital eye health to the mainstream. And he created a new revenue system besides affordable care for the people, touching human lives, particularly during the pandemic times. Over the last 2 decades, he had driving transformation by building leading edge and innovative systems for insurance, enterprise risk management solutions, and life insurance related sectors, and delivered so many solutions to global insurers in around 65 countries. Mr. Chandramouli is regularly featured in technology forums, and his transformation lecture series like Living on the Edge and The Art of Care are the practical examples of how technology touches lives and had been an inspiration to budding technologists and innovators to work on technology that matters. And currently, he is on the advisory board of GAVS Technology USA for new initiatives on health tech, on the advisory board of SimpleSolve USA for InsuTech transformation, as a honorary technology advisor at Sankara Nethralaya, Chennai. It is a great honor to have you with you, sir. Thank you for accepting our invitation and being here today. And we are excited to hear some words from you, sir. Thank you so much.
Thank you, madam. Before sir starts, in Shankara Nethralaya, sir was giving vision for millions of people. Now he is actually engaging with computer vision. So we have chosen the right person for inaugural session of PDP. With this introduction, let me now invite Dr. Chandramouli, sir, founder of PE1 Technology, to deliver the inaugural address. Please, sir.
Thank you, sir. Thank you for a very, very generous introduction. Let me first thank the organizers and the senior faculty and staff of SRM for giving me this opportunity to present my experience. I wouldn't say this is going to be a masterclass on data science. I'm just going to give you a practitioner's view of what's happening in the field of data science and what should be done. As SRM being a pioneer in the education, how do you channelize the future for your students and also your professional faculty members and taking it further. Without much ado, let me get into the presentation, which I shared a few slides. In fact, I shared these slides with Dr. Dileepan, just in case somebody would be interested. Besides the recording, I think you can also get those slides from Dr. Dileepan. Let me just share the presentation deck for the day. Dileepan, am I audible?
Yes, sir. Yes, sir.
Okay, good.
Yes, sir. Yes.
Thing is, most often, I think this so-called idea for data science is misrepresented or misunderstood, or it is too wide for you to take a very specific view of what needs to be done. So I'm going to talk about a few things that what needs to be taken care, because this is too vast a subject for you to cover in a 10-15 minute spot. But most importantly, understand what the underlying is, which is data. So I think there are three components in this whole aspect of data science. One is the data itself in the first place. Second thing is the science of doing things. And third is the technology driving that actually. So I'm going to touch upon all the three aspects of it during the course of the conversation and give you some practical examples of what can be done or what should be done. But what has happened post-COVID is the rise of a new idea called a digital economy. It is not that it wasn't there before, but it got accelerated. Almost anything that you can possibly think of today, which was more or less physical, whether including education, was now become virtual, or which is leading to a lot more newer opportunities and things like that. So, and data science in particular becomes a foundation of the digital economy. That's what I would say. So like I briefly touched upon, as you know, I will give you big ideas on what needs to be done from a data perspective and how do I navigate the data science myth, and also some industry use cases and getting ready for the future. In fact, there is a video which is already shared with Dr. Dileepan. Just in case we have some broadcasting issues, please bear with me. I think you can get an access to the video from Dr. Dileepan. Like what I told you is, you know, the underlying in the data science is understanding data. I think to give you the kind of a problem that we have today, we generate around 2.5 quintillion bytes. To give a number 0, it's around 18, you need to add 18 zeros beyond the 2.5. So that's the kind of a data that is being generated by people across the world, and bulk of it is user generated, not necessarily by the applications. And when you look into the macro picture of the internet users, close to around 65% of the world is already covered in some way or the other as part of the internet, and bulk of them were not covered. Roughly the 3 billion people are largely in the Asia, Africa region, which is likely to be covered in the next few years ahead. What is expected today is probably the next 3 years. I think we are not so far off. No, I think almost anything that we can talk about will be done by a machine, or what is called as the connected world. And roughly around 10 times more the population of the Earth, you are going to have devices talking to each other. So we are primarily redefining the whole idea of what is a mobile. Actually, we all understand mobile in a very, very narrow sense of a device where you pick up a phone and talk to each other. But it's already proven with all this IoT and other things. I think the connected devices is becoming the order of the day, and almost anything becomes autonomous. Actually, I think this is where the new world is going to look like. And in the context of what I said about this digital economy, the entire idea for data is completely getting blown up, actually, beyond all our human imagination that you can think about. And almost all the numbers that we talk about today will be absolutely meaningless in another 3 to 4 years now, because these are estimates, and we never know what the future is going to look like. But these are the estimates. Even the estimates are terrifying. So we are not only talking about only machines getting connected, but even our bodies are getting connected. In fact, I'll give you a snippet in the video which talks about those kind of ideas, because I come from 2 different industries. One is largely in the financial side, and also more recently through Shankar Nethralya in the health side, actually. And these are the 2 areas where there is a significant amount of technology adoption, and more so in the case of AI, deep learning, AI, whatever you may call it. We are trying to run many of those innovations out of these places, actually. And what defines data today? Because what are all the things that we may need to take when you look into the mega trend of making decisions on data and data science? The underlying is AI, ML. That's what everyone understands, which is fine. But a science by itself will be of no value without data in the first place. And how do you really look at data? I think these are all things that, because we want data to make decisions. Now, I think Professor touched upon what are all the things that you try to do with data. So you look data and try to make actionable insights out of data. So you will probably need some analytics. The transformation of analytics is already now into a cloud, instead of from being a desktop or a server based to something into a cloud. And where do you host it? I think it's where the technology is about, that is primarily on the cloud. And you need to secure it. I think that's where the cybersecurity is one of the key aspects of this whole stuff. And more importantly, today, most of the attacks are already automated attacks through bots, actually. So you use technology even to prevent attacks or to launch attacks, actually. These are 2 different dimensions to this whole story about using AI for good. In fact, I'm in part of those industries where we are trying to look at AI for good. And the user-generated data, which I just talked about in a slide away, I think it was more around the IoT and the so-called Industry 4.0 kind of an idea. So when you really look into it, almost anything that you do today, anything that you can possibly think and do, is now becoming data and data alone, actually. And the other aspect of what we are trying to do with AI is also, we are trying to disrupt the whole idea of even software development with AI. So it's just such a boring work for you when you're part of a data science team to sit and clean data all the day, on almost every other day. And there is a big gap between what the industry is looking at and what the developers can do. So we are trying to empower users with a lot of technology which can do data on its own, actually. So we have things like AutoML or a data robo, or automating the entire life cycle of the machine learning algorithms and things like that. I think those are things that are already happening. So there is a bit of a disruption even in the software engineering side of it. So at the end of the day, what you do is largely try to train your data with some of these models. So I'll come into some of those things in the next few slides. So where we are today is we are in some kind of an assisted mode where we are trying to develop models, help the algorithms and the computers to learn. But what is emerging is also some kind of an augmented intelligence where additional data needs to be captured. because this is probably missing and where the context is probably not understood. That's what even Professor talked about. How do I create the context? That's where the augmented intelligence really comes up, which holds up and open up a whole lot of information that is coming from these independent devices, things like IoT kind of stuff. Assuming now you are picking up you booked a car on your Google, I think you understand where you are from and what you want to do and what are all the services that are available in between, things like that, and it starts giving you data even during your drive. I think that's the kind of an augmented intelligence that really coming up today. Actually, that's already mainstream in certain industries, but I think this will become a mainstream in almost in every other industry in the next 2 to 3 years. And ultimately leading into autonomous intelligence. I say something like the driverless car kind of stuff, actually. I think that's, we are still not there, but I think almost many industries are looking at it. In fact, I was reading one of the reports a couple of days ago, even in India right now, for example, in Tata 1mg, 70% of these calls that they do for telemedicine is run by a robot. That's quite a number when considering that more than 1 lakh of telemedicine calls are done, transacted by the system. 70% of the calls are attended by a robot in the first place. Actually, that's quite a number for you to really talk about. So we are already seeing a lot of transformation happening in silos as far as the industry is concerned. What I call this is the digital abundance. So like what you saw around 2.5 trillion or billion data being generated every day. So we are having problem of abundance. So where do I remove this noise? I think that's where this making sense out of data is the biggest challenge today. So you have challenges in the cloud. So there's a lot of transformation happening around with more autonomous cloud coming into, or even industry clouds coming into. Then we have enabler technology, say something like the low code, no code kind of a solutions coming around. Disruptive technologies where we are talking about speech to text or not translating automatically most of these things into an autonomous mode. Then the next gen technology, say something like the quantum coming into picture. I think these are broad trends that we can do, but the underlying in all these areas is data. So data science, if you really start looking into it, you can't put a boundary and say, this is what I'm going to do in one way or the other. So we need to take a very narrow view what we wanted to do as an individual, as a specialist in some area or the other, start taking a particular point of view and start researching, because there is so much of work to be done, because there are global problems to be solved at scale. Thankfully, because of the internet and the same technologies that are available to the leaders of the world are exactly available to you and to your students or to anyone who is interested in the machine learning, deep learning, AI, sitting at home in a remote place, can really solve the world's problems at scale. I think that's the power of immersion, the innovation that you can do at scale today. So I think I just wanted to give a little bit of snippets into what we do as a data scientist. In one way or the other, the CIO or the CTO of a large organization, somebody like having worked in Shankara Nethralaya, and where we didn't do a lot of work around data itself. So what exactly I do? So one of the first things that you hear in any lecture or is you start building models. But the underlying is you're most of the time you're fighting with the data. And the data is a lot more messy or unstructured because it comes from almost all elements that you can potentially think around. For example, in Shankara Nethralaya, we take a lot of images of the eye. So you get data from the devices, you take data from a third-party data, taken a screening of the eye in some other doctor for a referral. They come here. We may have some telemedicine systems. We may book appointments, or there could be some lab which will give you some data of your basic diagnosis done and things like that. Almost everything is unstructured in some way or the other. So our biggest challenge is to remove the noise and make sense of the data and then create those kind of models. So model building is fairly structured in many ways, but the underlying is a lot more messy. So you need to have a different mindset to look at this, number one. The second thing is invariably you get into a conversation. The first thing is I have an algorithm which will solve your problem. But these algorithms are more high level. They may be specialized to a larger extent today, actually, but these are pretty high level. It may not be suitable for doing diagnosis, say in health, or looking at customer analytics, say in a retail or something like that. I think we may need to tweak it. I think we need to have some very independent view of what will work or what will not work. So the most important thing is not having an algorithm is fine, but having an algorithm, making it work is even more challenging because you need to know the boundaries of what it can do or what it cannot do and start tweaking it for data to the most relevant result. Otherwise, it's all garbage in, garbage out, actually. So an algorithm is not an one-size-fits-all stuff, actually. So most of the time that you really see is data science is also a one-man army. Probably there may not be more than one or two because you are trying to get into things which are very, very specific and contextual. So you may have one senior lead or a senior enough data scientist, you may call him, or whatever you may call him, to lead or provide a technology vision or provide some kind of a transformation vision. And there are a lot of people assisting him who could be a lot more junior staff who would be cleaning the data, creating sense out of the data, or to data analyst, who could make some sense out of it, come out with some kind of an R programming or do statistical analysis or create powerful visualizations and things like that. So it's largely some kind of a individual contributor kind of a role. So it's works narrow in very, very much in silos. So if you're thinking that any organization is going to have a 50-member data science team, unless it's a global company, something like a Google or a Facebook or something like that, then it's not going to be the scenario. So we need to qualify that. Then the question is, how do I fit it? If there is no one-size-fits-all type of an approach, it may work in one context or the other because there are hardly new data science-related engagement that may get started every day. Because the simple fact is there are no standard operating procedures how to define a new data science project and start from end to end. Actually, thankfully, I was in a couple of such kind of engagements. I think you might have heard Sundar Pichai talk about predicting the heart attacks based upon medical images out of the eye, actually. And that engagement, we started out of Shankara Netralia, which is a kind of a patented algorithm of Google today, largely done in collaboration with Shankara Netralia and Arvind Eye. So we sampled around 2 lakh images and had to remove all the bias and do a data analysis over a 2 to 3 year period, come out with predictive modeling and so on and so forth. And then finally, they're coming out with an algorithm which will be a supermodel to work for on a global scale. Today, we use it for multiple reasons across the entire spectrum. So here are some common business cases. This is not exhaustive, but I think you can really see most of this in action across the world. Customer analytics, fraud detection. I think I covered some of those things. Financial services had been one of the early adopters of algorithms because algorithmic trading had been something of working since 2000 itself. I was working on algorithmic trading for customers in US, even as early as around 98, 99, some of the biggest brokerages in the US actually. So stock trading adopted to algorithmic trading long time ago, much before this data science became a subject or some kind of a high, very buzzword today. And advertising largely, not anything on the digital, particularly on promotion, sales, marketing, customer analytics kind of stuff were early adopters. Now the late adopters had been largely on the health and medical, and because of the COVID, I think it got fast-tracked to adoption in certain areas, but medical recognition, image recognition, cloud deep learning had been the biggest contributors of the whole lot of transformation that you're talking around across the world today, across any industry. It now gets into, besides medicine, life sciences, I think you get into a lot more into automating the production lines, telecom, and so on and so forth. I think almost you name any industry, there is no dearth of AI adoption into any industry because the underlying is data. The typical life cycle, I think like what I told you, is there is no standard operating procedures. There is a lot of trial and error that you try to do before we get back into something which will be a workable model. But research is the most underlying thing that you can do. So typically what we try to do is, even before you get into a large scale transformation using data, you try to do a limited modeling with some kind of a sampling data, then you understand what can be done or what it cannot be done. Then we start tweaking that model into something more global level. I think that's what we try to do most of the time. So most of the data science projects are typically lab oriented projects which starts at a lower level, then it got scaled up. So you need to have a long-term vision of what you wanted to accomplish. And this is exactly what I did, actually. This is not something out of the box. I think this is something which we did over a longer period of time. In fact, it took us more than 5 years to come to some sense of a maturity. And we have done around 3 massive engagements on using data. One was where we can predict based upon an image of an eye about what is called as a diabetic retinopathy. It's a subject on its own. I can share some videos, which is already in the public domain. I think that was tremendous in terms that what needs to be understood is the doctors, it's a global shortage of doctors, not only in India, there is a global shortage of doctors, most of specialized doctors. I'll give you an example, like diabetic retinopathy, because India is supposed to be one of the largest population of visually impaired, not necessarily blind, visually impaired across the world, number one. Number two is we are also the largest population of diabetes, which is more a killer combination of eye with probably losing vision thanks to diabetes. And there was no prediction capabilities that are available because you never know that you have a problem like a diabetic retinopathy. And the number of specialists who can really diagnose for diabetic retinopathy is hardly around 3,500 in India. This was around 2-3 years ago. The numbers may not have changed dramatically because the annual input of the eye specialist or the retinal specialist is very, very low. So it's a bigger problem for us to really solve upon. So what we did was using medical diagnostics images, we picked up and using vision, computer vision, I think we predicted and that it kind of worked around 95% of the time. And what even researchers couldn't do, I think the algorithms were in a position to train and get things done. I think that's one side of the story. The most important thing that what we need to understand is the economic value that what this created was phenomenal, actually. If I were to put a number in terms of what it can potentially save, roughly around, India has really around 6 to 7 crore people to be screened. And you need to screen them for around 3 times a year at least. On an annual saving of what a per visit that you may spend around 6,000 rupees for screening, then you compute the numbers. This will be a subject or a work that each one of us can do in our lifetime forever on basic of screening of diabetic retinopathy alone. This is just one subject. I think this is also explains why I told you that it is important for us to take a very narrow view of what we wanted to solve on AI and data in terms of business. I think each of the dimensions of the problem are enormous for the humanity. So when I look into the roadmap for adoption, I think there are 2 other engagements which we did in Sanskrit Nethralaya, which is like predicting cataract outcomes and predicting LASIK outcomes. I think these are bigger data science related subjects where we can really predict post-surgery whether you'll get your vision back the way that you ought to be. So primarily the fundamental shift is data-centric and now trying to have an alignment between the man and the machine or the so-called AI algorithms. Third is most important thing is building trust, where you not only you secure, but also ensuring that it is explainable. Because you need to tell your customers or your patients or your doctors, fellow doctors, how you arrived at those solutions actually. So there is a legal aspect of it and they need to have a onus of you to explain it. And most importantly, the data science is not a domain of a practitioner. So you need to have some specialist, somebody like the industry specialist coming around helping you out. So a partnership is what is required. And most importantly, the biggest challenge in a data science project is the lack of data itself. I think we have also made first time a set of data as available as an open data sets for people to really explore and come back with innovation. I think this is what we have done. I think this is the kind of a roadmap that we need to have for each and every problem so that we can solve problems at scale. I'll give you a snapshot about what is ahead of the future and whether are we ready.
Sir, the audio is not coming, sir.
Oh, okay.
Please.
One second, let me stop the share and reshare.
Yes, sir. Yes, sir.
I personally believe that artificial
Is it coming?
Yes, sir. Yes, sir. Yes.
Okay.
intelligence, the robotics industry, will eventually become bigger than the automobile industry of today, because your automobile will become a robot. You will talk to it. You will argue with it. You'll have discussions with your car about the best route to take. And when you want to park the car, you simply tell your car, park yourself. And the car parks itself. This is going to revolutionize urban economics when you don't have to worry about parking anymore. And then the next organ to be digitized is the brain. You may not know this, but 2 years ago, scientists were able to upload the first memories. Memories can now be uploaded and downloaded. This makes possible BrainNet. BrainNet could be the next step in the evolution of the internet. Instead of zeros and ones, instead of text, you'll put emotions, feelings, sensations, memories. Teenagers will go crazy. Teenagers put happy faces at the end of every sentence. Why bother to do that when you can put the emotion of your first dance, your first kiss, your first whatever right there on the internet? And so in the future, when you walk into a room, you will mentally command the internet. You'll take dictation mentally. You'll turn things on, turn things off, communicate with other people. People will think of you as a wizard of some sort, mentally communicating with everything around you.
The longer video is already available. Perhaps I will share it to Dr. Dilip, and I think you can take a look at it.
Sure, sir.
The
Sure.
crux of the matter is, we are in significant times of change. The problem is, are we getting ready for, how do we get ready for the future? So there are three aspects to what I think we need to do. One is the future of work get redefined, number one. And what are the jobs of the future? I think that's equally the other part of it. We all understand data. But what are the jobs? Where are we getting into? And what are the skills that are required? I think these are the three dimensions that we really think. I'll just touch upon some of those things very briefly in terms of what we should be looking into it. This was again a study done by one of the big four. I think the future of world is going to be largely around the four areas of the companies which they redefine it as the four worlds. Innovation is bucketed under the red world. That's where we talk about all this data, the digital economy and all that stuff. The yellow world is largely around the human's compass. Somebody like where we do work in Sankaranathara, where we look into not-for-profit as a great idea, things like that. Then the green world is largely very eco-friendly or eco-sensitive stuff. I think that's the other side of it. And the corporate world is the blue world, where there is a lot of stuff which is driven around performance and so on and so forth. I am not getting into this as an idea right now, because this will be a subject on its own for a larger discussion. But whichever world that you're going to talk around, what is changing is important for us to understand. On the left-hand side there, you really see a lot of stuff around the changing demand, which is the topmost is your data analysts and scientists and AI and big data and so on and so forth. Almost anything that you have, a lot of stuff which has been manually done or getting extinguished, or those kind of industries doesn't work anymore. For example, the BPO kind of stuff, what is happening around probably will be completely taken over by bots. In effect, 50% of all the people that are in the world today who are working workforce needs to be retrained, because the fundamental shift is towards working a lot more. You have to be digitally literate, working a lot more with data and trying to work on new tools and technologies. So reskilling, upskilling, whatever you may call it, I think these are things that needs to be done. And these are all data which is published by the World Economic Forum. This is not my own data, actually. So the good news is we need to remove all the noise and probably look into what needs to be done very practically and narrowly. I think that's where some of things like your industry programs can really help you. Any new skill that you can possibly think, including data science, could be done around 5 to 6 months, not more than that. I think that's where things are moving around. I think this is again a study which has been done by the World Economic Forum, and the underlying in all these things is largely technology skills. You can choose any industry. It could be on your any of those 4 worlds that you look into, or depending upon what you wanted to achieve. I think the underlying is broadly into the technology, where there is a mashup of technology and business coming together and leading a lot more of cognitive. Actually, I think that's where the industry is moving around. And when you really look into your students who needs to be hired and trained, I think this is a quantum shift that you're talking around. I found a very, very interesting article published by the Wall Street Journals. Even before a job interview, I think the interviewer may probably know most of the things about the personality of the people, the testing, the skills, and what he is capable of or not. I think all these things would have been done by an AI or based upon public domain information. And the data will be presented to the individual for him to make a decision. And ultimately, what is going to determine his selection is his ability of the right brain of the job, or how innovative he is going to be. I think this is going to be the biggest challenge as far as the future of your jobs are concerned. So all these things apart, let's try to get into what India is doing and whether are we doing the right things, like whatever the technology trends of the world. I think I just wanted to give you some great ideas of what is happening and the changes that are happened in the last 5 to 6 years and what is coming up as well, and how you should, from SRM, be ready to handle this kind of a change. One of the biggest quantum shift that has happened in the last 5 years is a move towards a digital economy, or the so-called Digital India program. The Digital India program, in fact, the good news is one of my old colleagues who used to work together as the head of the Digital India, I know closely working with him on many of his industry initiatives and also what the government is taking on all the national programs and roadmaps and things like that. I'm talking to you with a lot more inside information about what is being thought through and what is coming up around. So the large programs are being where the identity is your core. It's where the other really comes in, which builds the India stack, which now ability to give you open up a bank account on demand. Literally, financial services had been transformed, and today 40% of the world's mobile platform is based out of India. Actually, this is the quantum shift that the world has ever done, and absolutely frictionless and faceless banking is today's possible. You can open an account to a bank. For example, I recently opened an account around a year and a half with IDFC. I don't even know where the branch is today. Completely, somebody visited my house, took a device, and it was completely a eKYC done, and the entire banking has been done. Within 2 minutes, I got a message and I opened an internet account and started transacting. And even today, I have never visited that branch. That's the kind of transformation that has happened in the financial services, particularly on banking. And you name it, similar is your telecom, mobility, food skills, health, and things like that. Health is a bigger change that is happening around with the National Digital Health Mission coming around. The same way that what we saw in payments are going to be done in health in the next 2 to 3 years. I'm part of those discussions. I've been part of those committees before set standards and coming out of the India's roadmap on what the future of digital health is going to look like. I think these are transformation times. So probably what I call it as the Y2K movement of India, what is happening around. Government services, almost you name anything that you are already getting into a digital mode right now. And we saw the biggest benefits or the direct benefit, the DBT schemes. Crores of rupees were transferred touchless, faceless from the government to the poor. And the underlying for all these things is around 60,000 startups, which has emerged over the last 5, 6 years. And to them, 100 plus are already unicorns. When you talk about a unicorn, it's a $1 billion plus valuation. I think this is the kind of a quantum shift that India has seen at a high level. Where it is heading is one of the fundamental shifts that we're really seeing is a creation of an ecosystem. We talk about Google, we talk about Apple, Play Store, all this kind of an idea, but India never had an idea for creating an ecosystem. So what India did differently was to create an open data stack, actually, where the entire transaction, where there is no kind of a digital monopoly or a data monopoly, because which was the biggest challenge. Because today, you know, if you wanted to buy anything, Amazon knows more about your buying behavior than your local merchant, actually. So India took a very different approach where we created what is called as an open digital goods, where a lot of leading into a lot of open source technologies provided by the government itself. For example, the India stack. You can technically go online, get an API done, your payment is done live, actually. In less than a day or two, you will be online with your payments. The open credit enablement network is largely some kind of credit rating, which is emerging right now. And the biggest change that you're really going to see is the transformation in your retail called the ONDC. If you're keen, I think you can go into the ondc.org to see what is changing around. So your last mile connectivity, including your Kirana store or your local mom and pop stores that you're talking around, will be completely on a digital footprint, where the e-commerce footprint of India will go up from 5% to 30% in the next 5 to 6 years, which will open up another couple of $1 trillion of commerce. You know, we are talking about a 5 trillion economy is a no-brainer. It should be a 10 trillion economy in the next 5 to 6 years, probably. Once this ONDC itself really could contribute at least around $3 trillion to the entire conversation. Then there are other bigger ideas around account aggregation. So you don't need to carry many things on your every time when you do a lot of stuff. I think these are all completely open source, where there are emergence of a platform which will really give you the data. If you're an innovator, you just go with all your basics. I think you'll get your data and create it. So what this means, and the National Digital Health Platform, which I talked about briefly. And there are things which are coming around, which include skills, voice, travel stack, and so on and so forth. I think these are things which are emerging. In fact, last week I was in the IIT where they were talking about some of this use of AI for some of these India-specific AI. I think this is open AI that is coming for India-centric activities, because we have a biggest challenge, which is largely our local lingo itself. We have multiple languages, and how do I solve problems at scale with using some of the language itself? I think this is something which is emerging. So all these things, what is likely to lead is we are already one of the largest data users right now, which we are not familiar with right now. I think all these data is going to be available to you as an open data set, depending upon what you are with some qualifiers. And we could be the India's world's largest data capital of the world. I think that's going to be the reality of the future. I do have one recommendation for SRM in terms of what we should be looking at. So you already have your centers of excellence and other things, or your computer center, data center, whatever you may have it. I think we need to start moving away from learning into doing. Actually, this is where because today it's all about skills. I think it's important that you need to move away from just learning into more into doing. Because like what I told you is, any new skill, you can master it in less than 3 to 5 months, depending upon what you want to do. And more importantly, particularly if you're looking at data and data science and the bigger opportunities that are coming around, you need to have a vertically aligned idea. It could be on any of the emerging areas. It could be retail, it could be mobile or telecom or health or manufacturing or anything that you wanted to do. Let's start thinking about how to get an industry-focused idea. And today, almost anything that we do, there is going to be a bot, right from cleaning your houses to the most sophisticated factories using bots. I think these bots are going to be the reality. A digital assistant, we are already using Google in many ways or the other. Almost everyone will have a personal bot in the next 2 to 3 years, at home, at work, so whatever you may try to do. I think so how to get friendly with a personal bot and do something which will be more important. I think that's what needs to be done. An industry 4.0 or an IoT is going to be the key for future. I think this naturally dovetails into your data science. And you need to secure it. Cybersecurity should be a very horizontal and also specialized area that needs to come around. I think it's there is no point in discussing. I think can understand it. You can do it for good. It can also use it for hacking and make the worst out of it, actually. So whichever way it is, it's from a national security point of view also, it's important. cybersecurity is going to be the key. So all in all, we need to reinvent the future. The reinventing the future is about building partnerships, trust, and more importantly, also involve the industry with angel funds and probably even get some grants for doing some great society-oriented benefit programs. And we should be in a position to create the IPs which can solve the world's problem at scale. I think that's what I would recommend the leaders of SRM to think and start looking at data science in a different perspective. In a nutshell, I think what I would like to emphasize is the future is already there. Only thing is we don't recognize it. It's already unevenly distributed. I think it's for us to make it a reality for everyone. Thank you.
Thank you. Thank you so much, sir, for your wonderful address. Indeed, you have kept the audience spellbound with your voluminous speech. Thank you. Thank you so much, sir. This is the time to invite our technical session guest. The world's greatest achievers have been those who have always stayed focused on their goals and have been consistent in their efforts. Let me call upon Mrs. Indumati, Assistant Professor NCA, to introduce the guest speaker for the day. Please, ma'am.
Audible, sir. Audible, sir.
Audible, madam. Audible, ma'am. You are audible, ma'am.
Good morning to everyone. I deem it honor and a privilege in introducing for guest Mr. Jyoti Periyasamy. He is Chief Data Scientist, Applied Machine Learning and Data Engineer, Instructor, University of California, Silicon Valley, USA. Mr. Jyoti is a co-founder and Chief AI Architect in DeepSphere, California. He is Head of Artificial Intelligence Expert 5 in Boston. He is Artificial Intelligence Learning Facilitator, Massachusetts Institute of Technology in Boston. Mr. Jyoti Periyasamy has 17 plus years of management consulting and end-to-end AI experience with Deloitte and KPMG. Over 50 plus clients across industries, health, energy, oil and gas, public services. He teaches data science, applied machine learning and data engineering at University of California, Silicon Valley in USA. He teaches AI at MIT, Head of AI, Architect at Expert 5 Hardware Innovation Lab. He co-innovates industry solutions along with SAP America. He published on finance, AI, big data, IIoT, cloud, and SAP appliances. He delivered many research projects on market for AI enterprise services. He globally recognized as a keynote speaker. He spoke at over 50 plus conferences. He recently invited by Prime Minister Office of Dubai, Malaysia, and Montreal. He is alumni of Stanford University. Mr. Jyoti has received academic and industry recognition from several reputed institutions. Pianoma, California Treasurer Office, USA, for providing the artificial intelligence workshop, have the students a new vision about their future as adult leaders and productive citizens with AI in the center of new digital era. He has also received appreciation from Xing Liu, MIT AI student, founder at Adley Liu Education, and also from Jurita, Program Manager, PNG, for his novel ideas and great thinking. Globally recognized keynote speaker and thought leader for finance, AI, digital IoT, big data, and data science by Forbes, CIO Review, and many organizations in Canada, USA, Malaysia, Australia, especially in Dubai at Prime Minister Office. Mr. Jyoti specializes in oil and gas, energy and health with a focus on finance, compliance, analytics, and data. Jyoti engaged with more than 50 plus customers across several industries. Mr. Jyoti educated and empowered more than 10,000 students in the field of artificial intelligence in Tamil Nadu, Telangana, and Andhra Pradesh at various reputed institutions like Anna University, SRM Engineering College, SRM Science and Humanities, VIT, SSN, to name a few. We are extremely happy to have such an eminent personality Amit with us today. Thank you, sir, for accepting our invite and gracious at this occasion. Sir, I invite you to take over the session. Please, sir.
Sir, you are muted, sir.
Please unmute, sir.
Yes, sir. Sir, can you all hear me?
Yeah, perfect, sir.
Yes, sir.
Okay, sir. Thank you so much. So, SRM is not new to me. I've been with SRM for almost now 3 years. Been spoken many events and heavily interacted with the students and also working with the faculties and designing curriculum and delivering many different research projects. And recently we conducted an internship with the SRM BCA students for the second semester. So once again, I sincerely thank you all for the opportunity. I really appreciate this. Okay, I do have my personal website in case if anybody wanted to know. It's jyoti.ai. It's everything what I do, it's here. Correct? So whatever madam told, it's all here. So you can see all my project work, things that I have done, what I've done at MIT, what I've done at Harvard, KPMG, Ernst & Young, Deloitte, so anything that if you want to know more about me, you can get to see this one. Correct? So it's all things that what I've done actually. So including people that I interacted in my life, it's all here. And recently I conducted a workshop with the people from Africa. It's a nationwide skill development for the African country, the continent. So it's all here. So you can get to know more about me. All right, let's move on. Okay, so I was asked to, Dr. Thilipan approached me. He asked me to talk about advancement in data science, correct? So there are great speakers here. They talked a lot about it, so they told you about from industry perspective, how things are working, and from data science, what the challenges are. So I do want to talk about the advancements. 1 second. I'm just trying to open a slide that I wanted to do. So my focus today, how artificial intelligence advanced, correct? So when we say artificial intelligence, I'll cover that, which is part of data science. Okay, so I'm going to talk about the advancement of applying data science and natural language processing and computer vision, correct? So there are some real use cases which we are going to talk. But what I feel, correct, before we go there actually, so we want to understand some fundamentals. Okay. On the 22nd, I had a session with scientists. Okay, when I say scientist, pharmaceutical scientist, the American Association of Pharmaceutical Scientists. So they are people done PhDs, many PhDs, correct? Now you can't count them, correct? So people who has done PhDs, they're doing clinical studies. They want to understand how do I use machine learning to do things around these areas. Okay, so they want to understand how do we use data science or machine learning to do bioavailability, okay, bioequivalence to the core, correct? That is how when you take a medicine, correct, how the medicine interacts with your body, correct? They want to discover that what rate it is impacting. Okay, so it is pretty extensive study I did with them. It's an use case. I'm just going to walk you through what extent data science could be used and how we can do this one. But before we get started with all the things, correct? Whether it's going to be how data science applied in bioavailability and bioequivalence for medical field, such as drug discovery, or if we want to go out and understand how artificial intelligence, machine learning, data science advanced in natural language processing, computer vision, correct? Such as understanding about transformers, understanding GNA, correct? So before we do all these things, what I feel getting to know some fundamentals is most important. Before even go to fundamentals, how does it work in real world, correct? So that is what I wanted to cover. Okay, so there are 2-3 applications I want to get started as a demo, correct? So that you can understand. So this is one of the applications that we built at DeepSphere. What we do, we provide personalized education. That means education is completely customized based on how the students are learning, what the students wanted to learn, what the students' interests are, correct? So here we are using natural language processing. So what we do faculty assistant. That means if a teacher wanted to teach a course, we provide content. Student assistance. If a student wanted to learn something, the subject is very heavy, correct? So if student wanted to have some kind of a study material, we personalize and give it to them. Okay, so we also provide other learning resources, lab material. If you want any of this material, we don't hard code, we don't go out and do anything. We use machine learning to create this content. Okay. Second, in terms of doing student assessment, correct? If you want to conduct a student an assessment, correct? Whether it's an assignment, quiz, or multiple choice, fill in the blanks, true or false, whatever it is, correct? So we use machine learning to create these things, correct? So I just want to demonstrate this one. And this is built and hosted on Google Cloud, kind of like, so what you're looking at, it's built and hosted on a Google Cloud. It's a real application. It's in production. It's used by 100+ universities and colleges at this point, correct? They are using this one. So how do you build an application at the scale, which is basically a machine learning application, correct? I just want to give a quick demo so that you can understand how it works actually, correct? So for example, so what I want to do, I want to create a content or I want to create a question. So choose anything what you like. And what are the models that's been implemented, correct? So these are the model that's been implemented here actually, correct? So these are the model that what we are implementing, correct? Okay. And second, what library we are using. These are some of the libraries that we are using. What are the Google Cloud services we are using? These are the services we are using. I believe Dr. Chandramouli was talking about data plays a key role, correct? In our case also data plays a key role, correct? So we need data. How do we get the data, right? So all the things, what it is, I want you to understand, so when you want to study data science, when you want to become a data scientist, or when you want to work in the field of data science, do not just think that what you study academically is going to be enough for you to do the work, right? There is many things involved. As I told you, you need to understand what model to be implemented. You need to understand what library or something that more appropriate for computing you need to use. And then cloud plays a very key role. So what are the cloud services you're using and how do you get data? Okay, so that's what it is. So let's say I want to generate a question. So that's something that I want to do it, correct? So I want to generate some questions. So to generate the question, it's asking me what kind of question you want to generate. So let's assume that I want to do a true or false, fill in the blanks, match the following multiple choice question, whatever you want to do actually. So let's say I want to fill in the blanks. When I do ask for fill in the blanks, okay, it's asking for give me the content, I will give you the question, correct? And then it tells you the steps it's going to go through. Okay, there are different models it's going to implement it, and these models are basically natural language processing NLP based models actually. So it could be one of them, it could be a BERT model. It's based on the transformer architecture that we are using. So it's asking me give me the content, I will give you the questions. So I'm going to select and give the content that what I wanted actually. So this content that what I'm looking for, it's in my local laptop. I'm just going to save this, select this one, and give the content you can understand. So what I want you to understand, correct? How do you build something at this scale, correct? So that you could use this one. So this is the type of application, what is expected to build this, correct? So this is the content I'm providing. It takes the content and goes through all the steps, okay? It reads the content. It goes through every steps that is involved, correct? So it tokenizes the sentence, extracts the keyword, sentence the keyword match, and then fill in the blanks questions, and it's going to give you the model outcome. So it's going to go through all the steps, correct? So you can see every step is going to be performed, okay? It's going to tokenize the sentence based on what you give. You can give anything, so we don't care what you give, correct? Any text you give, we'll give you back a fill in the blanks, correct? And it's going to extract the keywords. Okay, it's extracting the keywords. These are the keywords it's found, and any sentence keyword match, it's going to find out. So there is a keyword matching and the sentence is finding out. Okay, then it's going to create the fill in the blank question. Correct, so it does everything. Okay, so when you complete the model, you will understand the question is going to be given to you. So now it's going to generate the fill in the blanks. Okay, and then see the model outcome. So this is basically, if you notice, an end-to-end application built for question generation. Okay, so this is part of the natural language processing. In natural language processing, what we are doing, we are taking a question, okay, a set of paragraph, and then we create a fill in the blank question. So this is the question that's been created right now. You can see this one. So this is just one example that I'm trying to give you so that you could understand how to build data science application. So this application, so primarily based on the natural language processing. I gave a paragraph. The machine reads and understands the paragraph. It formalizes the question based on what you are expecting, correct? So I wanted fill in the blanks. If I want true or false, then it will give me true or false. If I want to match the following, it will give the match the following. If I want multiple choice, it will give the multiple choice. Let's say I don't want the question, I want the actual study material. Okay, it will give you the study material. You give a topic, it's going to give you the study material, correct? So this is the scale you are expected to build applications. Okay, you are expected to build applications. So here I'm just trying to demonstrate, correct? So how you can build application at a scale. So coming back here, correct? In case if I want to generate content, that means a textbook, correct? I don't have a textbook for the student to teach, or I don't have a way to create a particular study material to give. or any extra learning resource to give, so I can do the content creation here. Okay, so I'm just going to say data science. Okay, I need some content, more relevant content for student to study at a personalized level. Okay, so here I'm not giving the actual text, I'm giving the actual, like, the topic that I'm interested. So when I hit enter, it basically finds out everything that what I needed, correct? Like, so it's going to perform the, 1 second. Just a second. I'm just trying to see. So the point is, given the time, I may have to skip if it doesn't work. Actually, I need to see. So the point, what I'm trying to make you understand, correct? Like, you can build anything that you wanted, correct? You can build anything that you wanted in the power of machine learning and data science, correct? So it's absolutely amazing to see how things are working here, actually. So I'm just going to skip this for a minute right now. So I'm just wanted to show you one more thing real quick so that you could understand how does it work, actually. So the next one, it's a real application that what we built for a client. I'm just going to show you that you can understand. So this is an application that is built on Google Cloud as well. Okay, so this was built on Google Cloud for a customer to, it's a production system. So it's deployed in the production they are using. It's a global retail company. They operate almost all country in the world. So they wanted to understand, correct, the customer churn, and also when the customer is going to churn, why it's going to churn, how do we prevent this one, correct? So that's something that they ask us to build, we built. And this is a real solution that has been deployed, and it is heavily built on data analysis, data science, correct? So you can see, so this is the application. What you can see here, actually, it's a machine learning application. So built on Google Cloud using an application called Streamlit. Okay, so I want you to understand here, what are the library we are using? What are the models used? What's the Google Cloud services being used here? Okay, the first thing it's asking you, it's very interactive. So this is what business is looking for, correct? Business don't want it to go out and do something that's just by themselves. So they want to interact with the system. They want to understand how the system works, correct? So here, one of the requests for us to make the business user interact with the system and provide any response the machine is asking. Okay, the users should be able to train the model, test the model, deploy the model. The users should be able to provide any other information the model requires, such as providing features, providing hyperparameters, all the things the business wanted to do, not a data science. Okay, develop a retail machine learning application, which is for customer churn. Who's going to churn, when the churn will occur, and why it occurs, how do we stop them? Okay, all this part of the problem. So this is what the customer asking. Number one, who's going to churn? Number two, when it will occur? Number three, why it is occurring? Number four, how do I stop it? What's the customer interest? Tell me so that I can work with the customer. So here, the first one is asking me to select a problem. So what kind of problem? Customer churn. All right. Who's going to churn? I'm selecting this one. Now it's asking me what type of problem this is. It is a classification problem. That means I'm trying to classify, correct, whether the customer is going to churn, yes or no, correct? So these are the basics you need to understand, correct? It is not about just building the model, correct? What model you are building, how the model is going to interact with the users, correct? You need to understand this one. So here I have a problem, who's going to churn, type of the problem, classification, whether the customer is going to churn, yes or no. Yes, the customer will churn. No, the customer will not churn. Now it is giving me option. Hey, there are several models you can implement. What model you can implement? Decision tree. That's the most simple supervised machine learning model that you could implement. Okay, the most simple, easiest model that someone can implement is the decision tree. It's a simple supervised machine learning model, and it trying to predict whether the customer is going to churn, yes or no. Now it's asking me, hey, give me the training data so that I can train the model. Okay, give me the training data, I can train the model. So I have a sample training data for the model to be trained. Okay, I'm giving the sample training data. Keep in mind, these are all very built at a massive scale. There are many different system interfaces, correct? It's just not on a file. It interfaces with the SAP, it interfaces with the Google, it interfaces with the AWS, correct? It interfaces with many different systems to look at all the data points and do a preview. So if you want to understand what the data that you are giving for the model to learn, you can do a preview. If you want to click all the data to see the entire data set, you can click on like an entire data set, you can get to see this one. So these are the data sets that's been given for the model to learn, correct? I'm just giving you the sample for you to understand, correct? So this is one important point what you need to understand. As a data scientist, as a person who's going to learn data science, understand how do we construct training data based on what I'm going to do, correct? That is the key point. If your training data is not there, the model is not going to learn anything. Actually, it's meaningless, correct? All right. So now it is asking me, correct? You have given the actual data. Select the feature. This is one of the key requirements for us, correct? So the business user wanted to decide the feature, not us, correct? The business wanted to decide what the feature they wanted to use, correct? So here it gives an option to choose the price, okay? Why the customer is going to churn? Is it based on the price? I want to discover this, correct? Keep in mind, the business wanted to discover the features, not you have to go and tell that. You cannot dictate, okay? You have to tell the business. Or so it could be price, or it could be service calls. That means I'm keep calling the customer service, they're not responding to me, correct? It could be that. Okay, or it could be the lifestyle. The customer has been with me for a long time. They want to get rid of this. They want to leave me, or whatever it is, right? So you can select this one. So the feature engineering, it's one of the key functions when you build the models, when you train the models, like, it's important. So in our case, the customer wanted us to give the functionality of building a feature by themselves, correct? So they want to create this by themselves, correct? All right. So now I'm going to click on extract feature. So this is the feature the model is going to use to learn this one, correct? So I understand, okay? I want you to understand all the steps is most important. All the steps are easy enough for you to understand, okay? When you know the fundamentals. When you don't know the fundamentals, and that's when things get complicated, correct? The next one. Now I want to tune the model. I'm not going to tune the model at this point. Actually, if a model doesn't perform well, then I'll come to this point. Now I'm ready to test the model. It's asking for, like, so I'm ready to train the model. It's asking for, do you want to train the model? In parallel, we also write code. Okay, we generate codes as well, correct? So I'm going to click on train the model. Now the model is getting trained. Okay, so one of the things that what they want us to do, they want us to build a code generator. Okay, we created a code generator. So behind the scene, what happens? It creates the code. Automatically somebody can understand how to train the model and etc. Correct? All right, the model has been fully trained. I'm ready to test the model. I'm going to go ahead and select my test data, which is basically like a data that I wanted to use for the model to be tested. I'm testing the model, correct? So I'm testing the model right now. So now what the model is supposed to do, the model is supposed to predict whether the customer is going to churn yes or no, correct? So that's basically what I wanted to see. So here it's asking me to preview the test data. You can see the test data if you wanted to. If you don't want, you can skip them actually. So this is the test data that I'm giving. I'm going to click on test model. So now the model is going to basically perform the testing, and it's going to give me whether the customer is going to churn, yes. Under what probability the customer is going to churn and what probability the customer is not going to churn, it's going to give the accuracy. Okay. So now what I have done, I've done the entire life cycle. So this task, what the business asked us, they want to do this by themselves, not by a technical person, correct? Not by a technical person. So the business want to do this by themselves. So we build this app on their level of commitment and interaction, correct? So they worked with us. They wanted what they wanted. So it's a custom build application based on what it is. But you need to understand the steps that what we went through, correct? So define the problem, select the type of the problem, select the model, train the model, give the features the model needs to understand, and then train the model, test the model. So now the model is ready for analysis. So we also build data visualization. Okay, so this will allow the user to analyze the data, correct? So a lot of the speaker already spoke about, like, how do you analyze data and all those things. So we build a functionality for the users to analyze the data. Okay, so the user can analyze themselves. So this process that what you're looking at, it's an iterative process. The business wanted to do this by themselves by changing the features, changing the hyperparameters and etc. So they want to do this by themselves, correct? Like, so this is 1 second. Okay. Yes, so this tells me, correct, who's going to churn, who's not going to churn, what percentage of customers is going to churn, what percentage of customers not going to churn, and how many customers are male or how many customers are female, and what is the reason for that, like, so this basically tells you what is the reason for a customer is going to churn. Is it the product quality, the service request, the product cost, etc. Okay, what is the trend is going to look like, correct? Like, what is the trend is going to look like, when this churn is going to occur, correct? So these are all different type of analytics we built on top of the model outcome. Okay, so based on the model outcome, we build this one. Okay, so I want you to understand, correct? So what I am trying to demonstrate here, building data science is just not like, writing a piece of code and loading data from an Excel spreadsheet and done with that. No, there are many things involved. Many things involved. If you want to build at a scale or a real business, there are a lot of things involved. One last topic, then I'll go to my presentation. SRM reached out to us. Okay, so this is still in a pilot. We have not fully done. SRM asked us to build a digital dashboard. What the digital dashboard does, correct? Regardless of where the students are, correct? Whether it's campus 1, campus 2, campus 3, at any given point in time, we want to understand 3 things. Okay, a student facial recognition, where the student is. Second, student activity, what activity the students are doing. Third, the tracking of their attendance, correct? Like, so where they are. So this is still in a pilot. Okay, we have not fully built it. It's still in a demo. So hopefully this week we'll be done with it. So this is also again completely built on Google Cloud. Okay, so this is built on Google Cloud. So this is some of the model that what we are talking about. So we are going to implement this on the Google Cloud. It's already there actually. Okay, so here what I'm trying to say, it's a computer vision. Okay, it is an application, understands students' facial recognition, understands and predicts students' activity, and records students' movements in the class and time and everywhere, correct? Like all the things. So when you select this student facial recognition, it tells you, correct? So these are all samples, don't get confused, okay? So now it's going to, in a live, let's say you have a camera, surveillance camera that records the students' movements, correct? When the students comes in, it records everything, correct? In a live camera, so we recognize students and then we also tell their students actually, okay, oh my God. Okay, so again, it's still in a working state, so it could be issue, so I have to figure out, but I'm just trying to tell you. So this is an application we are trying to build for SRM on 3 things, correct? Like, so this is coming along. Maybe once I'm done, then I can see if that's going to work. Just a second. If it doesn't work, then I'm going to move on. So it will. It's a live stream. It reads a camera. It tells what activity they are performing. Actually, it's going to take some time because it's still processing. Once it's done the processing, it's going to tell each and everything that happened in that video. It's going to tell them actually, correct? So what it does, it tells you what activity somebody is performing, what activity they may perform. It's going to predict as well, correct? It's going to predict that too. So again, all we are using some sample stuff. So okay, it is not like SRM students or anything actually. So this is still in the development. We have not fully done. So I'm just trying to tell you, correct? So this is another type of application you can build. So this is a computer vision based application. So what we looked at, there are 3 different applications that we looked at. One is applications built on natural language processing for question generation, text processing, language modeling, sentence classification, words classification, etc. We looked at another application where the industry is really needed for predicting customer churn, when the churn is going to occur, who's going to churn, why the churn is occurring. So now we are talking about another application which is needed for SRM for tracking students' activity, predicting student activity, facial recognition of students, and time recognition of the students' movements and everything. Okay? So these are the type of application you can build typically using data science or a machine learning based kind of like technologies. All right, so with that said, let me start some fundamentals. Okay, like I said, I'm a strong believer in understanding fundamentals. I just wanted to make sure you also understand fundamentals, correct? So going back here, so I had a session with, I told you, pharmaceutical scientists on the 22nd. It's a 90-minute session. So they're all PhD people, okay? So they wanted to understand, how do I use machine learning? How do I use data science in my clinical study? I cannot recruit 200 people. I cannot recruit 200 patients, correct? I need a better mechanism. I am working with him, build a platform, okay? So what it is. So this is basically what I covered. I'm just going to skip some of those things, okay? So rest are we already talked about. So in my view, there are core building blocks of artificial intelligence everybody must have to understand. What is the core building blocks? First, we need to know what is artificial intelligence. Second, we need to know what's machine learning. There is a huge confusion. I have seen people who studied in MIT, Harvard, misrepresenting the words of machine learning and deep learning, correct? It is shocking me. It is absolutely shocking me why they are saying that way. So these are all things not clearly defined, or at least people not understood well. So understand what's artificial intelligence, what's machine learning, what's data science, what's intelligent automation and digital transformation. Keep in mind of all the things what we talked today, correct? So we had Mr. Chandramouli, who spoke about a lot of industry experience. No matter what he spoke, all falls under here, correct? Whatever he talked about, it's all comes under here, correct? So of course there are various technologies involved, correct? So but the core concepts, principles, all coming here actually, correct? So we must know all the things very well. What's artificial intelligence? What's machine learning? What's data science, intelligent automation, digital transformation? In my view, these are all mystery. People are not able to understand well enough. Okay, so let's understand this. Then we can go back and understand how we can advance these in our day-to-day work or things what we do on a day-to-day basis. All right. So this is again basic things. So things like reading, writing, cooking, driving a car, or doing some diagnosis on a disease, all the things what we do on a daily basis based on our jobs, correct? If someone is a doctor, they do medical diagnosis. Somebody's a driver, they do driving. Somebody's a cook, they will cook, correct? Things like that, correct? So these are the things what we do on a day-to-day basis. Okay, so if you look at this more closer, okay, there is some level of intelligence involved. I cannot drive a car just like that. I need the rules and regulation how to drive a car, correct? So that is called intelligence. Okay, driving a car, it's an intelligence. Who's driving the car? A person. And who's the person? Driver. What we call them, that is an intelligence coming out from a human. It's a human intelligence, correct? Why it is a human intelligence? That happens through a formal or informal training. You cannot go out and drive a car. You must have to understand, like, you know, all the rules and regulations, and also how to function a car. That needs some kind of a learning, some kind of a driving. Let's say next example, medical diagnosis. So when you go to doctor's office, the doctor's asking a series of questions, correct? Okay, what happened? Why happened? This and that, correct? So those are all an intelligence. Not anybody can ask this question. Who's performing this one? A doctor. And what do you call human intelligence? Why you call human intelligence? Because that doctor went through some medical training, correct? They may have done medical courses, or they may have done a lot of different things. So with that, they are able to do this one. Let's take another example, coding, programming, correct? So what is this? That's an intelligence. Not anybody can code, correct? Can I code in C, C++? Yes, I can. Can I code in Java? Yes, I can. Can anybody can code in C, C++, Java? No. Why? It's an intelligence you need. Okay, who's performing? A programmer. And what do you call them? Human intelligence. Okay, so why? It's done by a human. Okay, how did the human get this done? Through a formal and informal training. Let's summarize. So if you look at intelligence, correct? If you look at intelligence, correct? It could be something that you can talk about: reading, writing, speaking, decision making, solving problems, and etc. Those are all intelligence. Such intelligence performed by a human, then it's a human intelligence. There are intelligence, it doesn't need a training, correct? So if a human is getting a knowledge or an intelligence, that could be in a formal or an informal training. So there are intelligence happens without any training. Such intelligence are called emotional intelligence. Okay, such intelligence are called emotional intelligence. Correct. Now let's understand what is artificial intelligence. Correct. Artificial intelligence, by definition, it's an alternate substitute replacement for all the three. Okay, you can do an alternate, you can do a substitute, you can replace the entire thing, correct? So it could be any intelligence, it could be a human intelligence, it could be emotional intelligence, correct? So that is basically what is artificial intelligence. So by definition, when people say artificial intelligence, it's an alternate substitute replacement for any intelligence that you could think of, any intelligence. It doesn't matter what it is, correct? So we need an alternate, we need a substitute, we need replacements. All right. So how do you apply this in industry? Okay, how do you apply this in industry? And this is where data science comes into picture. Okay, you apply artificial intelligence in industry in the form of data science or an intelligent automation. Anything else, absolutely crap, ignore, correct? You cannot do anything, correct? So if you want to create intelligence artificially, it has to be only in two forms, either in the form of an intelligent automation or a data science. Intelligent automation, an automation occurs without a human or no manual work. There's no manual work, there's no human involved. Data science, extract hidden insights on data, apply science, correct? Not just going out and discovering here and there. You apply science. So the point what I'm trying to make you understand, we understand what's artificial intelligence. It's an alternate substitute replaced for human, emotional, or any intelligence that you could think of. How do you apply this in industry? Only in two forms, rest all ignore. Okay, so if you want to apply artificial intelligence in industry, you can apply in the form of a data science, or you can apply in the form of an intelligent automation. So when you combine these two, it forms a digital transformation. Okay, when I combine these two, correct? This is what the core of digital transformation. Without this, it's impossible to build anything. Okay, it is impossible. So now let's understand what's an intelligent automation. I'm sure you already heard about the self-driving autonomous car. A car functions without a driver. So what I told you, an intelligent automation, no human, no manual work. There is no human involved, there is no manual work involved. What exactly it means? So if you look at the autonomous car, there is no driver sitting in the car and driving the car. So that's no human here. No manual work. So when a car on a constant speeds, the car sees a red light, it stops, it's green light, it moves, it's yellow light, it slows down. So that is not a manual work someone has to tell the car. It functions by itself. So this is why it's called an autonomous car, self-driving autonomous car. It functions by itself. So it's an industrial revolution. It's an industrial automation. And the industry is looking for to automate this kind of equipments, correct? So here, if you notice, we are automating in a car, which something that used to controlled by a driver, it functions by itself. Such automation, it's the intelligent automation, the intelligence of a driver artificially created inside the car. Okay, the intelligence of a driver, such as when to stop, when to go, when to slow down, etc. All the things are intelligent. All this intelligence are created artificially inside the car using machine learning models. All right. So data science we talked about. Okay, in a simple word, there's many different definitions. People completely misrepresenting data science, correct? In a simple word, extract hidden insights, apply science on data. Okay, applying science on data is this data science. What kind of science we are talking about? Bayesian tree, random forest, logistic regression, correct? These are all examples. It could be neural nets, correct? You apply this kind of science on data and extract hidden insights. In this case, correct, this is one of the work that I have done for Dubai Hospital, correct? They want to find out length of stay, patient demographic information, clinical information, fitness information, lifestyle information. Use this information. Tell me the patient length of stay, readmission rate, discharge rate, behavioral patterns, correct? So I no need a doctor to do all these things. Okay, a intelligence of a doctor created artificially here. How? Data science. How? Data science, correct? So you don't need a medical degree. You don't need to be a doctor to do this one, correct? So you can do this one by yourself using artificial intelligence, machine learning, correct? So point what I'm trying to make you understand. Apply science on data, extract hidden insights such as length of stay, readmission rate, discharge rate, behavioral patterns, and these are all data science. Why does this falls under artificial intelligence? These things are typically done by a doctor, a medical professional. Okay, here we are saying we no need a medical professional. We can do this ourselves by using data if we have that data. Okay, so that is why it's data science. So the next point, what we talked about, digital platform, correct? Like, digital, how things works in digital platform. The best way to understand, you can take Uber, DoorDash, correct? So these platforms are operates at a scale, correct? Anywhere in the world, correct? I'm in US, my families are in Coimbatore. I can book a taxi for them while I'm here. I can order food for them while I'm here, correct? How? It's a digital platform. It enables me to do things across the world, correct? So there is no manual work involved. There's no human involved, correct? So they have my credit card, they can process the payment, they have currency translation, everything is done digitally, correct? So point is, okay, so we need to understand what is artificial intelligence, what's an intelligent automation, what is data science. When you combine these two, it forms a digital transformation. So this is absolutely a fundamental learning everybody must have to understand. Okay, I have seen people talking without any basis about what's artificial intelligence, what's intelligent automation, what is data science, what is digital transformation, correct? All these are all absolutely really important before stepping into anything bigger, correct? So learn and understand the fundamentals. All right, how does all these things possible? Okay, how does all the things possible, correct? How do I create intelligence artificially? How do we create digital transformation? How do we create intelligent automation, data science, and etc.? The only way you do, teach the machine. The only way you do, teach the machine. That is most important. That is what machine learning does. So the machine learning enables you to teach the machine so that the machine can understand what a human can do and perform this task. Okay, so the machine can understand what a human can do and perform these tasks. So the point what I'm trying to make you understand, if your goal is to create intelligence automation, data science, digital transformation, you must need to learn machine learning. Teach the machine. Okay, so now the question is, how do I teach the machine? What do I teach the machine? Okay, it is fundamentally most important, correct? Before you get into more statistics, mathematics, and all the things, correct? Understand the basics, understand the fundamentals, understand something that very simple terms, correct? So how the machine is going to learn? Okay, my goal is to what? Teach the machine. How do we teach the machine? What the machine is going to learn? So the machine is going to learn based on two approaches, either a statistical based learning approach or a neuron based learning approach. Simple. Okay, the second point is like, what the machine is going to learn. You ask yourself when you go to the school, when you go to when you go to classes, like what do? You learn from the teacher. How? When the teacher speaks, you're learning from the speaking. That is the language. When the teacher writes something on the whiteboard, you watch something. That is the vision. When the teacher is giving a problem for you to solve, that's basically like your homework or assignment. That's a process you are going to do. So what the machine is learning, the machine is learning language, vision, and processes. Okay, so that is what we are talking about. Okay, so when we say machine learning, what we need to understand, what the machine is learning, how the machine is learning. If the machine is learning through a statistical based learning approach, there are certain architectural components we have to select and follow. If the machine is going to learn based on a neuron-based learning approach, there are different architectural components we have to select and learn from this. So that is where deep learning comes into picture, correct? Like, so where you can teach the machine, where the machine can understand like a human, correct? Like a human. So where the machine can use statistical based learning approach, it learns from there, correct? So there are approaches you can see. These approaches dictates the underlying data and architecture. How the machine is learning. If the machine is learning language, then it's a natural language processing. If the machine is learning vision, that's a computer vision. If the machine is learning processes, robotic process automation. And that is what we are talking here, correct? So we are talking about like a human, you as a human, you see something, then you understand. You speak something and get a response, you understand that one. You do something, you do, that's a process, correct? So this is basically vision, language, processes. Okay, vision, language, processes. So this is basically one of the most important points for you to understand. So when you want to teach the machine, how do I teach the machine? What the machine is going to learn? The machine is not going to learn anything beyond these things. Either the machine is going to learn the vision or a language or a processes, correct? So whatever process that is going to be. So that's why you see computer vision, natural language processing, robotic process automations, correct? You see there is a computer vision, natural language processing, robotic process automation, all the things comes into picture. So what we understood, correct? So how do we teach the machine? Okay, so the only way we can teach the machine, it's basically like, train the machine. How do you train the machine? We need the data. Okay, so what the machine is going to learn? So the machine is going to learn either a vision or a language or a processes. How it's going to learn? Either a statistical based learning approach or a neuron based learning approach. So if you understand all the things, then it will be much easier for you to go further deeper into the space, correct? Then we can specialize in each one of those, correct? So the next point, what we need to understand, something basics about the machine learning, fundamentals, correct? Like, so I'm not going to go deeper into this one, but I just wanted to cover a few things so that you can understand. Okay, so when we talk about machine learning, correct? Let's take an example. You are a student. Okay, you are a student. How are you learning? Correct? You're learning from a textbook. You're learning from a lab. You're video or audio, whatever it is. Correct? Similarly, the machine also learning from the data. When a machine learns from data, so what is the key thing that what we need to know? So there is the big data, IoT comes to the picture, correct? So that is also one of the key things when you want to study data science. The expectation is that you should know big data and working with like, IoT kind of a platform or a sensor kind of a platform that where we can read and understand the data, correct? So it is explicitly assumed or understood that any data scientist must have to have skills and knowledge and expertise in big data, IoT. So that is also required, correct? So so the machine learns from the data. And how does it the machine learns, correct? As we looked at, correct? We always start with the problem statement, select the model, okay? And collect the required data. Train the model. The model builds an algorithm, learning algorithm, and test the model. If the model performs what you expected, then go down. If model doesn't perform, repeat the steps, correct? Repeat the steps. This is how you do it, correct? So the demo that I did, you can understand from that point, correct? So that is what the business want to do. If the model doesn't meet what I expected, I want to repeat this whole process, correct? I want to change the data. I want to do something. I want to do all the things, correct? So we want to provide that information, that kind of approach, correct? So just to show you like how the model is learning and all, okay? All right, so some real world application that what has been built actually, correct? Like, so this is, I done a lot of work in healthcare. I worked for Blue Shield of California, Kaiser, Bristol Myers Squibb, Takeda Pharmaceutical, Atalis. There's so many different companies that I worked on. So here is some of the use cases that built for the healthcare, correct? So that you can understand how you can apply data science, how you can use data science. So all these use cases, like I said, like, so could be basics. It could be any extent you wanted to build. So this is just some of the thoughts you can have. So how do we listen? Okay. So now in this use cases, what we done? Okay. In this use cases, we implemented supervised machine learning, unsupervised machine learning, reinforcement learning. Okay. So let's go one by one. Okay. I'm going to skip this one. All right. So what is that we want to do? Okay. So one of the things that they ask us to build, segmentation, patient segmentation. So the patient segmentation is basically based on the patient's, like, disease condition, many other factors. Correct? I'm just going to give you simplify this so that you can understand. Correct? So one of the problems that they ask us to do, patient segmentation. Okay, so I'm just going to walk you through with the real examples so you can understand like what model is implemented, when did we use supervised, unsupervised, reinforced model, and etc. So here, what we are calling about, like, so we wanted to find out the patient segmentation. When we say patient segmentation, there are two approaches the company want to do. So the company already had some traditional software engineering method, their hard-coded rules, and they were not working well. They also want us to introduce machine learning based model to do a patient segmentation. Basically, they want us to find out, like, patient's ethnicity with many factors, right? So that's what it is. So if you noticed here, actually, in the traditional way, you hard code this one. If height is this, if weight is this, okay, then you say this person is, this is the ethnicity of this person. It is hard coded, it is inefficient, it is impossible to do this one. So here, I'm not doing this one. So what is happening here? The machine learns and understands the patterns. When there is any change in the data, it automatically detects and understands. Here, I have to hard code. Okay, here I have to hard code. So this is what the client was doing. They were doing this approach, and we introduced machine learning based approach. Correct? So this is more efficient. So here you see height, weight, color, eye, body size, ethnicity, and etc. Correct? There are many factors involved. Correct? So this is just only samples I'm talking about. Correct? So what do you call these things? So these are all called features. Correct? So these are all in machine learning world. All these are all called features. Correct? So these are all called features. This basically what the machine is learning. Correct? So when you are trying to build a machine learning models, the number one thing what you need to understand, what are the features basically you need to use to make the model to learn and understand the patterns in the data sets. Here, my goal is to do a patient segmentation. Okay, my goal is to determine whether the patient is white, black, Asian, etc., and along with some disease conditions and etc. So I don't have the entire thing. I'm just taking examples. There are two approaches. One is a traditional software engineering, one a machine learning based approach. In the traditional software engineering, they were hard coding all the things. When there is a change in the data, this is not going to work. Okay, it has become inefficient. Here, I'm not hard coding anything. Instead, the machine learns and understands and builds its own learning algorithm. It understands the patterns in the data sets. Correct? So if the height is this, weight is this, color is this, then it tells it's an Indian. Correct? Like this. So in this context, these are all called features. These are all called features. Correct? So this, I'm going to skip this one. So this is basically what we introduced. Correct? This is basically what we introduced. We introduced a self-learning, no hard-coded rules, adapting business changes as and when it occurs. Correct? So benefit of what the machine learning model does. Correct? Second is most efficient and highly productive. Okay, less cost to manage as compared to human-developed automation. Machine intelligence and human intelligence, correct? So ultimately, the intelligence what we build, it's a machine intelligence. So what I'm trying to say, why companies wanted to go into machine learning based approach? There are things you won't be able to do. It is something that quite challenging. So from that point of view, the company wanted to go into this approach, correct? So the company wanted to go into this approach. All right. So there are 3 more slides. Then I will go into the use case that what I was trying to talk to you. So there are type of machine learning that we wanted to understand at a basic level. So the number one is a supervised machine learning. Okay, when we say supervised machine learning, what does it mean? So there is guided rules the machine follows to learn. Those guided rules must, if it is not, the machine will not learn. Example, it is most important for you to understand why, when you go into advanced topics, if we don't have fundamentals, you have more challenges to understand. Example, when we talk about GNA, correct? So those type of models, it's kind of built based on supervised, unsupervised model. If we don't know what the supervised, unsupervised model does, then you will have problems. So that is why learning the fundamentals is most important. A supervised machine learning model, what is it is involved? The name itself tells the machine is learning under supervision. It's a guided supervised model. So basically the model is learned based on a supervision. So here the training data must have to label. The machine must have to have a goal to achieve, which is it has to have a target to predict. Okay, so these are the things the machine has to understand. So what type of problem this can solve? One is a classification problem or a regression problem. It is important. If you noticed in my demo, I selected the problem type. The problem type is what I'm talking here, classification or a regression. Classification could be binary class classification or a multi-class classification. What is classification? I'm going to have a predefined set of values, correct? Yes or no, true or false, pass or fail, male or female, correct? So these are all classified values. Okay, so is this person is going to churn, yes or no? Yes, the person will churn. No, the person is. It's a binary class classification. Okay, is the patient going to live or die? Okay, so yes, the patient is going to live. No, the patient is not going to live. Okay, so in this case, it's a binary class classification. Okay, so this is basically like, I'm trying to classify your data. Okay, so based on the features that has been given in the form of binary class classification or a multi-class classification. So that is one type of problem a simple supervised machine learning model solves. Okay, the second problem, okay, it's a regression problem. So the regression problem, it is not a classification, it is a range of value. When I say range of value, what I'm talking about, how much the house is going to cost, or how much the person is making, or how much the cost of this car, correct? So here it is not a classification, it is not a classified value. It is basically a range of value. It could be 100 to 200,000. How much this house is going to cost? 100 to 200,000. How much time it's going to take travel from Chennai to Coimbatore? It may take 8 hours, or it may take 8.5 hours. Okay, it's a range of value, so that's a regression. Okay, yeah, simple supervised machine learning, okay, solves two type of problem. One is a classification problem, second is a regression problem. Understand this one, it is important. In your data science, correct? When you want to build data science solution, the first thing is define a problem. The second is choose the problem type, correct? What kind of problem I'm solving? And this is the problem I'm solving. Second, what type of problem it is, whether it's a classification or regression problem. So based on the type of problem, then you can select a model. Okay, so in this case, correct? So we are going to select a simple supervised machine learning model. Okay, so what are the different model we can implement under this one? It could be a decision tree, it could be a random forest, it could be a logistic regression, it could be a linear regression, okay, etc. So these are all some of the models, algorithms you can implement, correct? So first understand what is a simple supervised machine learning model. A simple supervised machine learning model, the model learns with the guided principles approaches. What is the guided principle? The model training data must have to have a label or a target. The model has to have a target to achieve, the goal to achieve, correct? So these are the guided principles the model uses to learn the algorithms, correct? So it's going to use that one to learn the algorithms. So here we are solving two type of problems. So one is basically a classification problem or a regression problem. Classification could be binary or a multi-class classification. So classification is a classified value, true or false, yes or no, male or female, etc. Okay, range, it is not a classification, it could be range. How much time it's going to take travel from Chennai to Coimbatore, or what is the distance between two places, correct? How much salary this person is making. If someone is working for 20 hours, what's the salary they're supposed to make, etc. So these are all range of values. That's a regression. What model we can implement? Linear regression, logistic regression, decision tree, random forest, etc. These are models implemented. Some of the use cases that we talked about: customer churn, when the customer is going to churn, why the customer is going, patient length of stay, how long the patient can stay in the hospital, correct? Like this actually. So these are some of the use cases that you can use, correct? So please understand, before you go out and build any data science solutions, understand what is a simple supervised machine learning, correct? So the reason why it's called supervised, the model learns based on a guided principle. What the guided principle? The training data must have to have a label, and the second, the models has to have a target to achieve. That is what it's the guided principle. The next is, I'm going to skip all this, the next is going to be a simple supervised and unsupervised machine learning, okay? So what is the unsupervised machine learning? Basically, it does actually so this is basically tells you that, okay, the model is basically don't have a goal to achieve. There is nothing that model you expect from here. In a supervised machine learning, the model must have to produce an outcome. In an unsupervised machine learning, the model don't have to produce anything. Why? When you're forming a cluster, there's nothing that what you're looking for is there. If it is not there, it will not produce any outcome. Correct? So here it's an unsupervised machine learning. The model don't have to have produced, the model don't have to produce any outcome. Point one. Point two, in the model training data, you don't have to give the label. There's no expected outcome data output in the model training data. Okay, so if such, what kind of problem we can solve? We can solve clustering, association, anomaly detection. These kind of problems you can solve. You can use the data. You can use the unsupervised machine learning to discover what data you can see. So I was talking to you about the clinical study that I was talking about, bioavailability studies. What they wanted to conduct, so with worth of 100 patients. It is practically impossible to recruit 100 patients, but they have data sets, correct? Previously conducted studies, but they are not sure whether they can use the study, correct? So they are not sure whether they can use the data. They want to discover what is inside the data. So in that case, we were trying to tell them to use a simple clustering model where they can form the cluster to see what data inside, what data they have, and what is inside in the data. Correct? So in the clinical study, they were not sure what kind of data they have. So they wanted to use clustering algorithm to see what data it is. If the data has any symptoms for asthma, diabetes, correct? So they want to find out these things. How can it do? So that is what clustering does. So clustering let you form the clusters based on the correlation with the data sets, correct? What it does, correct? So here, the point what I wanted to make you understand, if you are trying to create a data science application where you don't have to produce an outcome, correct? So there is no expected outcome from the model, or there is no label for the model to learn and understand, correct? So that is nothing like that. So you are trying to do data discovery, trying to find out what data inside, trying to correlate two data sets, trying to find out an associate to one data set with another data sets, correct? Find out an anomaly detection. So what, so all the things, if you want to do it, it's simple unsupervised machine learning. Okay, it is simple and unsupervised machine learning. So what are the different models you can use here actually? So you can use the models like so hierarchical clustering, dimensionality reduction. Okay, so K means all these are all K nearest neighbors. These are some of the models you could use. Okay, all these are all examples. I'm not saying this is the only example, only model that you want to use. So here you can use customer segmentation. Okay, target marketing. All these are all some of the use cases that you could implement here, correct? So this is just basically I'm trying to tell how to use it, correct? All right, so I'm not going to go deep into all these things. So this is enough for this. Now, let's move on to the advancements topic. Then I'm going to close the session at that point. Okay, so what is the advancement happening in the space of natural language processing and computer vision? Okay, keep in mind, technology plays very massive role in these things. Okay, so I just wanted to talk about transformers. So then generative adversarial network, correct? So these are the two key points we wanted to understand. All right, so if you look at where and how the advancements are taking place. So number one, a lot of industry use cases, a lot of people wanted to explore and use data science machine learning to do this work. Okay, so there is more and more industry use case people are wanted to explore. There are model architecture, correct, which drives advancements. Cloud and technology drives advancement. The user adoption, okay, users started adopting these kind of solutions. That drives this one. Of course, by connecting all, correct, so what is connect all of this data? So now there's a lot of data available, okay? How do we use it? And how do we extract and process these things? There are so many different technologies available at this point. We can stream data, we can batch process, you can real-time data, whatever you name it, it's there. But it's not easy, correct? It is not easy. Why? You lack business, correct? So it's not like a raw material where you can go and buy and use it. So it needs a business insights as well. So you may not be able to use this one. So what I want you to understand, okay, the advancement in data science, the advancement in data, natural language processing, the advancement in computer vision, driven based on number of industry use cases, model architecture, cloud and technologies, user adoption, of course, data. All the things drives the advancements. Okay, so we looked at these two demos. I looked at the NLP demo as well as the user adoption. This is basically like the customer churn. So now let's understand what the generative model does, correct? So here, if you noticed here, I'm talking about an unsupervised machine learning. I'm also talking about a supervised machine learning. If you don't understand what is unsupervised machine learning, what is a supervised machine learning, obviously you may not be able to follow these things. Okay, you may not be able to follow these things, correct? So what we learned in a supervised machine learning, you have a model trained with the labeled data, and you expect the model to produce an outcome. There is an outcome expected. You give an input, you expect an output. In an unsupervised machine learning, you give an input, you don't have to expect an output because there could be an output, there may not be an output, correct? You don't know this one. So the generative models uses an unsupervised learning approach where it's lacking for an output for a given input. And the model generates the sample output based on the inputs, correct? But still it generates the output. So generative model is able to generate new examples from a given sample data, in case given samples, and also from a different samples as well. Okay, it will not just use what you give, it will also take different samples based on the similarities. Okay, based on the similarities. So that is what unsupervised machine learning does. Typically use Naive Bayes classifier. That's one of the most commonly used one. Okay, so that is basically primarily used for discriminating network. Okay, so the point is when people talk about GNA, okay, it is two models, okay, two network trying to compete each other, okay, to create or generate variance in the data. Okay, so this is basically what it does, correct? So at a high level, okay, if you want to go deeper into this one, we can, correct? So there are two models. There is the generator model, there's a discriminator model. So these two models trying to create or generate variations in the data. Okay, so see what data you are giving and see what variation it sees this one. Okay, so we need to understand what is generative models, what is discriminative model, like a supervised machine learning model, where the training data has labels, outputs to be predicted. Okay, you have to predict the outputs. Okay, so that is basically the approach the discriminative model takes. Okay, the generative model uses unsupervised machine learning. So these two models compete each other and to create variance in the data sets, variations in the data sets. So what are the examples that we could see here? Okay, so the one that what we are trying to use for SRM. So what a student can do, the prediction of students' activity, that's built on GNA. Okay, that's built on a GNA. So we watch this camera. So based on the student's activity, we predict the next activity. If there is any suspicious activity, the student is going to perform yes. If such, we can prevent them. We can immediately talk to the student and prevent them. So this is one of the use case, predicting students' activity in a surveillance cameras. Correct? So in a classroom, there's a camera. We watch the camera and then predict what the next activity for the student is going to do. So that is one of the things as an example. And the second example, what you do, text to image. You give a text, then you generate an image. Okay, so object driven. Okay, it is an object driven. Okay, so this is basically one of the another use case what you may have seen. Correct? You give a text, it creates an image. Correct? So I wanted to give a text and then I want to create an image. So this is you can see in a lot of places. Okay, so if you want to create a visual image based on context, okay, this is what I want to do. Okay, so object driven text to image synthesizes via adversarial training. Okay, adversarial training. There are two steps. So first is generating the semantic layout of the image based on the given word, whatever word you are giving. So here I have given a group of people running, group running. So that is a word. It creates a semantic layout. Second, it generating the image by synthesize the images by using convolutional image generator. Okay, so understand the image layout and captions and refine the details of the image by synthesizing the words. Correct? It connects the word to the image and synthesizes. Correct? So this is another use case where you give a text and then model creates an image. Okay. The next one, I wanted to do image translation, image to image translation. Okay. So this is basically a model to identify different aspects to an image. Correct? So typically what you see in a police investigation, the investigation team wanted to analyze how someone may look and what are the different looks and feels of the person. Okay? So this is basically trying to get a real image and generated image and reconstructed image. Correct? You can see how somebody looks. Correct? So this is another one. Okay. So PCI to PCI model for general purpose image reconstructed image translation. Okay, so general purpose image to reconstructed image translation. So this is another use case you can build using GNA. Okay, so the next is what we have actually, enriching image resolution. Okay, the resolution of an image, correct? So the image is not clear to me. So during an investigation, I have an image which I can understand partially, but I want to enrich the image. How can I do? Okay, so that's basically super resolution generative adversarial network, or SRAR gone. Okay, so this is basically another model you can implement in GNA for enriching the resolution of an image, correct? So during the investigation, we don't have the full image. We wanted to enrich the image. How can I enrich the image? You can use this model. Okay, so the next is interactive image generation, correct? So I want to interact with the image, correct? So based on someone's body language or body movements, correct? The image also wanted to interact with me. So typically you may have seen in the gaming, television shows, okay, and advertising, correct? So people do all these things, correct? So you can interact with this one. So if I want to create an interactive image generation, then I can use GNA. Okay, so these are some of the use cases you can use. So keep in mind what does GNA does. It is technically, there are two competing neural network. Okay, it trying to create or generate variations in the data. Okay, so there are two competing neural network. It trying to generate or create variations in the given data set. Okay, so one is using a supervised machine learning, another one is using unsupervised machine learning. Supervised machine learning, where you have a label and a target to achieve, and unsupervised machine learning, no target, no outcome. Okay, so these two competing each other. So this is basically a generator network and a discriminator network, which is trying to work together and compete each other and get the things what you want. So what do you want to achieve using this one? You can predict students' activity in a surveillance camera. You can also transform your text to an image. You can also create different look and feel of an image to image translation. You can also enrich an image. You can also create an image in more interactive way. So these type of applications you can build. All these application falls under computer vision. Now you have technology, now you have data, now you have model architecture, which enables this one. Industry is also looking for these kind of use cases. Industry also interested in building these kind of use cases. All right. So the next one, I quickly want to talk about this one. Okay. The advancement in natural language processing. Okay. So what we may have heard about it, encoding text, language modeling, transformer learning, but the most popular transformer model. So typically what you see in a natural language processing, you give an input text, then the machine takes the text and process this one and creates. So what we noticed in our demo, I give a paragraph. What the model did, it understood the paragraph, it extracts the keywords, sentences, and matches the keywords and sentences. It framed a question, fill in the blanks question. That is what I wanted, question I created. So this is how it does. So this is completely advancing right now because of the transformer architecture and transformer learning and the BERT model and extra. Correct? So I'm not going to go like a lot more deeper into this one. Just wanted to make sure you understand. Okay. So here there are different type of approach for language. So all these things, correct? Whatever we talked about, correct? So if you noticed here, all the things forms under language modeling. Okay, word classification, text classification, okay, sorry, text summarization, question generation, sentiment analysis, machine translation, named entity recognition, all the things, correct? It's kind of language modeling. Okay, so this is basically some form of knowledge about a language required here. So to do all the things, we need some form of knowledge required. That means we need to understand what is verb, what is noun, and etc. Okay, and this is where the transformer learning comes into picture. Okay, so the point what I'm trying to make you understand. So this language modeling, okay, involves three different approaches. Approach one, word to vector. Approach two, a recurrent neural network model. The third is the transformer architecture. So here, continuous word representation, contextual word representation, contextual representation bidirectional, correct? So both right and left. So basically what we are trying to say, okay, how the industry is evolving right now. So it started with word to vector, okay? You give a sentence, I will tell you what the next sentence, okay? I will continue to predict, okay? I won't be able to go right or left. I won't be able to understand the context. This does not understand the context. This does not do any bidirectional. So here we have a context, but we don't have a bidirectional. So when I say bidirectional, correct? So for example, I'm saying, where are you, correct? So I want to predict the next sentence. So it could be two ways. Where are you going? Okay, so that could be going could be one way. Or where are you now? Correct? That could be another way. How do I know whether I want to predict going or now? That is contextual driven, correct? That's the context driven. So that context driven was introduced here, but that context is not right and left, correct? It doesn't go on the back, it doesn't go right and left. So this is the transformer model, which basically allows you to build the bidirectional representation, correct? Bidirectional representation. So these are all very advanced concepts, okay? It will take more time for me to explain to you. So I'm just giving you, make sure you understand. So the industry is evolving in language modeling, building application using natural language processing, correct? So here we are talking about word to vector recurrent neural network transformer, correct? So word to vector, a continuous word representation, recurrent neural word, contextual word representation, transformers, contextual bidirectional word representation. It is important for you to understand, correct? So this is, again, each one will have its own session, correct? So we won't be able to go deeper into this one. So I'm just giving an example. What is language modeling? What is transfer learning, correct? So basically what it is, correct? So you learn and understand all the things, correct? So some kind of a language you are learning about, either it's a verb or a noun or whatever it is, correct? So that basically you want to transfer, okay? Obtain the knowledge once and reuse them in a different parts of the application, correct? So that is what BERT does, correct? That is what BERT does, correct? So the BERT model allows you to do that one, correct? So the BERT model allows you to do this one. Actually, transfer learning, okay, it's a pre-training plus fine-tuning, correct? So when you say transfer learning, so the BERT is a transfer learning, okay? You pre-train the model and then fine-tune the model. So that is what basically transfer learning does, correct? So, all right, I do have a lot of content to talk about it, so for example, so one of the work that what we are doing, so that is completely built on a BERT model, correct? So, okay, sorry. So you could see this is a BERT model that what we implemented. It's a real model implemented. I can go any extent. Okay, it's on a Google Cloud. So I think it's enough for me. So I'm going to stop here. So please let me know if there's any questions so far. I can happy to answer any questions. So I'm going to stop.
Yeah, participants, if you have any questions, you can interact. I think there is no question, sir.
Okay, sir. Thank you so much.
Thank you. Yeah, thank you. The best and beautiful things in the world cannot be seen or even touched. They must be felt by heart. Gratitude is the memory of the heart as this delighting program comes to me. I consider it a great privilege to call upon Dr. Uma Shankari Madam, Assistant Professor MCA, to present the vote of thanks. Please, ma'am.
Thank you, sir. Before that, I request the participants to give their valuable feedback in the feedback link, which I've given in the chat box. Requesting all the participants to provide your valuable feedback in the feedback link, which is given in the chat box. Thank you, sir.
Sure. So, madam, they are asking for the PowerPoint presentation. So it's in my personal website. I will upload. They can download it. It's called jyoti.ai. It is there. I will upload there. They can download it from there actually.
Sure, sir, definitely. Thank you, sir.
Again, one more, madam. So
yes, sir.
There are many topics. I didn't even go too deep into this because it's a 90-minute session. I wouldn't be able to cover a lot of things. So I just touched at a high level. So if there is any specific question, they can still reach out to me through email.
Sure. Sure, sir. Is there any question from the participant side? You can also post your questions in chat box if there is any question from the participants.
Yes, if you have any questions, you can post in the chat window. So I am in the US time. It's 10:45 for me. So thank you so much. Yes, so I will give you my mail ID as well. So in case.
Yes, yes, sir. Okay. Yeah. Gratitude is the fairest blossom which springs from the soul. I deem it honor and privilege in proposing oath of thanks. First and foremost, I express my sincere gratitude to the management for providing this opportunity to conduct virtual PDP program. I thank our management for being a strong pillar of support in all our endeavors. My heartfelt thanks to our Dean, College of Science and Humanities, SRM Institute of Science and Technology, Ramapuram, Vice Principal Academics, Vice Principal Admin, and our Head of the Department of MCA for the never-ending guidance and support. I take this opportunity to thank our Chief Guest, Mr. S. Chandramouli, sir, Founder and Director, Pion Technologies, Chennai, for kindly accepting our invitation and delivering the inaugural address today. I extend my gratitude to the technical session one speaker, Mr. Jyoti Periyasamy, sir, Board Member, University of California, Chief AI Solution Architect, DeepSphere USA, for spending his valuable time amidst us today. Thank you, sir, for enlightening us on machine learning concepts, types of machine learning, artificial intelligence advancements, transformations, and language modeling. It is very informative, and we are getting a lot of appreciation from the participants in. Thank you so much, sir. I would like to express my sincere gratitude to all the resource persons of the various technical sessions and the delegates for the enthusiastic participation in this professional development program. I also acknowledge the unwavering support received from the faculty members and the non-teaching staff. My sincere thanks to all the participants from the various city college for their overwhelming response. My special thanks to our young and dynamic students of MCA and BCA Data Science for their contribution. We assure the sessions ahead will be more beneficial and informative to all of us. Thank you all. Thanks. Thank you, sir.
Thank you, ma'am. Thank you, sir. Thank you all. Take care. Bye.
Thanks a lot. Thank you, sir.